Here we go live. Not live. I don't know. It all blends together. Who knows where we are, what we're doing, quarantine life, normal distribution, and z-score. Let's do it. Exercise 1. Alex has a challenging course load taking physics and calculus. He got back his most recent exam grades in both classes and was disappointed with his performance. He began to feel better once the teacher reported the mean and standard deviation for the class. When compared to his classmates, in which class did he do better? Explain, hint, draw a bell curve. Alright, so we're going to have two bell curves, right? One for physics, one for calculus. Alright, so the mean, here's a bell curve, mean's in the middle, 50 percentile. So for physics is 72. And now the standard deviation is 1.5, right? So the next standard deviation would be 72 plus 1.5, which would be 73.5. If you want to go another standard deviation from there, it's going to be 74.75. And then you could do the same thing for below. Alex's grade was a 78. So Alex is a smarty pants sitting way up here. That's past the third standard deviation. So he's in like the 99-something percentile. Then you look at calculus. The mean was 88, so it seems like everybody did well in that. And no, I lied. That was Alex's grade. Sad face. The mean was 82. Alex's grade is somewhere over here at 88. Now the standard deviation was 4. So if you went 4 standard deviations, that's 86. And then you go again, that's 90. So then the standard, Alex's grade was an 88. So he's sitting right here at 1 and change standard deviations from the mean. So since he was 3 plus standard deviations, that means he did better in his physics class than he did in his calculus class. Now, calculating a z-score. So the z-score is the number of standard deviations a piece of data is from the mean. So here we were just kind of indirectly looking at it by seeing, okay, how far he was from the mean. And that's what we're going to call a z-score. It's the number of standard deviations you are from there. So a positive z-score means you're above the mean. So if that number was positive, you're above, and if it was negative, then you're below. So now here is how simple it is. So in a normal distribution, which the mean is 50 and the standard deviation is 6, what is the z-score? So what they're saying is you're going to subtract your score, okay, whatever that was. In this case, the first one is going to be 56. Then this is going to be the mean, and then this is going to be your standard deviation. So then the standard deviation here is 6, so that's going to be your denominator. The mean is 50, that's going to go there, and then your score would be this one. So here is going to be 56 minus 50 divided by 6. 6 divided by 6 is 1, that means you're 1 standard deviation away. So here is going to be 47 minus 50 divided by 6. That's negative 3 divided by 6. That's negative 0.5. So you're below, that's why it's negative, half of a standard deviation. Here we're going to do 41 minus 60 divided by 6. Why do I keep saying 60? Or I don't know if I keep saying, I just said it. So 41 minus 50 divided by 6, that's going to be negative 9 over 6. That's going to be negative 1.5 there. And then you're going to be doing here 65 minus 50 divided by 6. That's going to be 15 over 6. That's going to be 2.5. Okay, so that's just telling you how far away you are. All right, so 3. A population has a mean of 102.8, a standard deviation of 15.4. If a data point has a z-value of 1.87, what is the value of the data point? So in this question, basically what they were giving you was they were giving you the mean. Okay, there's your mean, 102.8. They were giving you your standard deviation, 15.4. Now, they didn't actually tell you your score. They told you that your z-score was 1.87, and then they want you to find what your score was. So what that's going to look like is 1.87 equals, you don't know, minus 102.8 divided by your standard deviation, which is 15.4. Now we're going to do some 9th grade algebra. We'll multiply by the denominator to get rid of it. So then we're going to have 28.798 equals x minus 102.8. Add the 102.8 from both sides, and you're going to get 131.598. Okay. Exercise 4 is a recap of the last question. In a normal distribution, which a mean of 56, standard deviation of 8, what percent of the scores lie between? So that's going to be your normal CDF. So I'll do the first one with you as a normal CDF. So the normal CDF, to find your percentile, remember first is your lower bound, then it's your upper bound, then it's your mean, and then it's your standard deviation. And then using your calculator, you'd be doing second vars, normal CDF. Now again, if you're old school, you have to put them in and hit comma. If you're new school, then it has just a list, and you're just typing these in and hitting enter. And then that's going to give you a decimal. You go ahead and you multiply that by 100, and then it gives you your percentile. And here is 68th percentile. All right, if you want to hit pause, try B and C, see if you're going to get the same answers. I'll write it down so you can see. 52, 60, 56, 8. That's going to be the 38th percentile. Here's going to be 56, 68, 56, 8, and then that's going to be the 43rd percentile. Okay. All right, let's turn it over. Keep rolling right along here. If you want to hit pause, try it yourself, but before you do that, change this one from proportion to percentile. Okay, we're just practicing our normal CDF here because it's asking you to find your percentile. So high school levels of cholesterol in blood increase the risk of heart disease. For 14-year-old boys, the distribution of blood cholesterol is approximately normal with a mean of 170 and a standard deviation of 30. So they're giving you your standard deviation and your mean, so you just have to find your lower and your upper bound. So remember, in the last question we just did, I'm telling you the number to start and the number to end. Right? Now, if they don't, you have to figure out, okay, are you above? Then you're going to go to infinity, which we call the 1,000. If you're below, you would do negative 1,000, which is infinity, to whatever that number is. So A says, what percentile to the nearest of 14 boys have cholesterol over 210? So if you're over 210, that means that the lowest number you can have is 211. The highest number, we don't know. It can go all the way to infinity. Your mean is 170, your standard deviation is 30. Bingo, bango, boongo, put it all in your calculator, multiply it by 100, and you're going to get 9%. Okay, it was 0.85 multiplied by 100, 8.5 rounded to 9. B, what percentile of boys to the nearest 10th? Ooh, nearest 10th. Have a cholesterol between 158 and 228. So you're going to do your normal CDF at 158. 228, so there's no 1,000 here because I gave you a start, I gave you a stop. Your mean, your standard deviation, 62%. No, I keep saying percent, 62nd percentile, 9th percentile. Let's say 1%. I guess it depends on how you like to look at it. So if a doctor has 200 14-year-old boys in her practice, approximately how many would she expect to have below 164? So if you're below 164, you're going lower than that. So the lowest number is infinity. The highest would be 163. Then your mean was 170. Your standard deviation is 30. You're going to put that in your calculator and you're going to get 0.42, blah, 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 blah. Now this is your percentile. This is how many you have. Multiply that and it'll tell you how many, or approximately how many of them, it's 84, would have cholesterol below 164. Next one. On the driving range, Tiger Woods practices his swing with a particular club hitting many, many golf balls. When Tiger hits his driver, the distance ball travels a normal distribution with a mean of 304 and a standard deviation of 8. What percentile to the nearest percent of Tiger's drives travel at least 290? So if you're at least 290, you're 290 and above. So you're going to do, the lowest would be 290, that's at least. The highest goes to infinity. His mean was 304. His standard deviation is 8. put that all in your calculator. So 96% of Tiger Woods' drive would go above that. What percent of it would travel between 305 and 325? Between 305 and 325. So I'm giving you your lowest, I'm giving you your highest, and then you use your mean and your standard deviation. And again, we're doing the normal CDF here, which is second bars. Okay. What do I get? Multiply by 100, 45%. And the last one here. The average weight of a full-grown beef cow is 1,470 pounds with a standard deviation of 230. If weights are normally distributed, what is the percentile rank of a cow that weighs 1,750? Okay, so now what you want to make sure you're doing here is you got to pay attention. So it's saying that the mean is 1,470. Now the cow is up here at 1,750. So when I try to figure out my normal CDF, I'm going to do 1,750 is the lowest, 1,000 is the highest because I'm above. Then I'm going to use my 1,470 and my 230, it's not really fitting, 230 as your standard deviation. Throw that all into your calculator and you're going to end up with 76%. All right, awesome. One more and we're done.